Dear students, see the next one from 11th standard, motion in the straight line chapter, relative velocity. Okay. So for example, let's take one object. Okay. Or let us imagine like as car. Okay. Now it is a road. Okay. Now one car is here. Now the car is rest position. Okay. So let us imagine it is the ground. It is the car. Okay. With respect to the ground, the car is rest now. Correct or not? Yes. Now the car is moving. So, with respect to the ground, the car is moving. Okay. At the same time, with respect to the car, the ground moving backward direction like that we feel. Okay. That is one of the relation. That relative motion. Okay. Right. Now, let's take two cars. Okay. Now, it is the initial position. For example, it is the starting position. It is the origin. Okay. So, now one car is here. Okay. It is the car 1. Car 1 is here. Okay. Right. So, from the initial state to this origin to the car position, say for example, okay, it maintaining some distance. Okay. Right. Then one more car is there. The car 2 is here. Car 2. Okay. Now car 1 is here and car 2 is here. In between the two car, the distance, for example, 5 meter gap. 5 meter gap long. So car number 1, car number 2. In between gap, the 5 meter distance. Okay. So now how we can compare that relative motion? How we can say the relative motion? Maybe suppose if the car A is okay, A is 50 km per hour. Okay. Then B also 50 km per hour. Okay. So the gap will be the constant. Okay. See that the both cars simultaneously moving with the same speed. Okay. So this is car A, this is car B. Okay. So the car A velocity is 0 with respect to car B. Likewise, car B velocity is 0 with respect to car A, because both maintaining the same speed in the same direction. Okay. So suppose the car A is maybe 100 km per hour. The car B is 50 km per hour only. So at the time what happened? Car A is overtake the car B. So at that time we feel some relative velocity. With respect to A, some value in B. With respect to B, some value in A. Okay. So that kind of feelings only we are going to discuss. The name as relative velocity. See that. So the relative velocity means what? The rate of change of relative position of one object with respect to the another object. Okay. So A and B what happen actually? The position will be changed. With respect to A, B position will be changed, and B with respect to B, A position will be changed. So that relation only we are going to discuss in that relative motion, in the relative velocity. Okay, I'll give some example. The same thing only like that. See that if an object A is moving with velocity VA, object A, let's say take this is object A moving with velocity VA, okay, and object B with velocity VB. So this is object B, its velocity is VB, okay. Right, VA velocity, VB velocity. It may be 50, 60 or otherwise 20, 40, anything. Simply we set VA and VB velocity. Okay. Then how to say the relative velocity? The relative velocity of object A relative to the object B is, okay, that is VAB is equal to VA minus VB. This is the general formula for relative velocity. Okay, here specifically I mentioned for relative velocity of A with respect to B. So that only mentioned as VAB. Okay, here major main velocity is A only I represent. Okay, velocity of A object with respect to B. So VA minus VB. Or otherwise we can write one more way. Velocity of A object, how we know this is 50 km/h? With respect to the ground, this is 50 km. This is 40 means how we know? With respect to the ground, this is 40 km. Now I am moving here. How you know I am moving? Because my back side is the board is rest position. So now I am moving here and there. So you feel I am moving, then the blackboard is rest position. Okay. Then one more thing, this opposite camera is rest position. Now let us imagine the camera also moving, I am also moving, the board also moving. If it is the same speed means again you feel rest position. Okay, right. So this kind of example you already observed in that while seated in a railway station or in the train, inside the train or inside the bus, you felt. Okay, right. So now we can say that the relative velocity of object A with respect to B we can write the relative velocity of A with respect to the ground minus relative velocity of B with respect to the ground. So that is one more formula. The same meaning only. So that only I wrote here VAB means what? VBG means what? VAG means relative velocity of A with respect to the ground. Like that, relative velocity of B with respect to ground, that is VBG. Okay, now you got this formula. It is very important. Okay, right. Now we discuss some special cases. Maybe both having the same speed or different speed or whatever. See that. Case 1. If VA and VB should be equal. Okay, so the relative velocity of A, relative velocity of B should be equal. So what happens? The both will be traveling same speed. So some observers sitting in the B, some observers sitting in the A. With respect to the A observer, B observer is rest. With respect to B observer, A observer is rest. Those who are sitting near the window, they feel that. Okay, the same thing only here. If the both velocity will be the same, so VA minus VB is equal to 0. VA equal to VB. That means what? VA minus VB is equal to 0. That means what? Relative velocity is 0. So, the relative velocity is 0, then how to express in the graph? That only I am discussing here. See that. Then the two objects A and B stay at constant difference. Constant difference. See that. Here, car A, car B. Both will move the same speed. Okay, they are maintaining the same distance in between them. So that was, okay, that constant difference is there from the beginning to the end. Okay, so that only they mention that the two objects A and B stay at constant difference and their position and the time graph, we get straight line. It's very important. We get straight line parallel to each other. Okay, see that here. Okay, so say for example, this gap, for example, here to here, from origin to here, 2 meter. From origin to here, 4 meter. From origin to here, 6 meter. So now at the starting time, okay, see that, starting time, object A and object B, the gap how much? 2 meter. Object A, object B, starting time, initial time 2 meter. Then after some time, the same distance maintain. Again, sometimes same distance, 2 meter, 2 meter, 2 meter, 2 meter, 2 meter. So the same distance will be maintained. So only we got straight line as well as the parallel. Okay, so the meaning of this graph, what is that? The relative velocity of, what is that? Relative velocity of A object with respect to B, or otherwise relative velocity of B object with respect to A is 0. Okay, so I hope you understood. It is the case 1. If the velocity of A object and B object should be equal, means what happened? Okay, right. So next, in case 2, if VA, velocity of A object, is greater than velocity of B object. Okay. So you know, listen, this is A object, this is B object. Now the question is what? Velocity of A object is more. Okay. For example, this is 100 km per hour. Velocity of B object is less. For example, 50 km per hour. Okay. Now started. So initially, this is A position, A object position. Then this is B object position. Okay. But the time is increasing. You know, this is 100 km per hour, the 50 km per hour only. So both will be moving, but on particular time, in particular distance, it will be cross the object B, correct or not? Object A or car A to cross the car B. That is one point. One more point. In previous case, that is case 1, that distance will be constant. Correct or not? Yes. But now, the velocity of A object is high. So the distance is reducing. Okay. But previous case constant. The gap is constant. But in this example, the gap will going to reduce finally to reach. Okay. So that point is keep in mind. So listen, if velocity of object A is greater than object B, so velocity of object A is high value comparing with the velocity of object B. Okay, it is a high value. Velocity of object A is high. It is a more value. It is a high. So high symbol. Velocity of object is high. Okay, comparing with velocity of object B. So what happened? Object A is to cross a particular point. So it will be object A line, object B line. It will be cross a particular line in particular distance, particular position. Then from this graph, how do you know the velocity of object A is high? See that object A, this is object A, this is object A slope. The slope is maximum. If the slope is maximum, velocity is maximum. But object is B, see that less slope. Okay, object A slope is bigger. So the velocity is more. Slope value more means velocity is more. You know that point. Already we discussed in the position and the time graph. So like that here, that slope value more, the velocity more for A. But if you observe that B slope B is lighter than tilted. So the velocity is less. So object B velocity is less. So here clearly we know object A velocity is greater than the object B velocity. So at a particular point, velocity of the car A to overtake the car B at particular point. So the point is after time is some time t and then some position is there. So what we learn from this graph? See that? The one graph is steeper than the another. Then they meet at the common point. See that? இப்போ ஒரு கிராஃப் மாதிரி இன்னொரு கிராஃப் இருக்கு. ஓகே, A graph, அது மாதிரி இன்னொரு graph, B graph. Okay, at the same time, see the distance is constant previous question. So in the previous one, the distance is maintained constant. But here see the distance initially, when time increasing, distance is reducing. Distance is reducing. Distance reducing. Reducing. This gap is reducing. See that this gap is reducing. Gap reducing. Gap reducing. Finally zero. At particular point is here. Again it is increasing. The gap will be increasing again. How? How? Because object A, object B, initially some distance. Then distance reducing, 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 zero. Then again, distance is increasing, increasing, increasing. So that is shown here. Okay? Okay, students, I hope you understood what happened if the velocity of A object is more comparing with object B. What about this graph? Okay? Next we will see case 3. Case 3, suppose let's take two objects in the same area, VA and VB. Both will travel in opposite direction. Okay. You know very well. For example, it is a bus A and bus B. Bus A, now you are sitting in bus A. Bus A 50 km per hour. Bus B, okay, 100 km per hour. So while it is crossing, you feel, you know very well, comparing with your bus, another bus somewhat speed. Okay. But at the same time, you feel very slowly it will be cross. Okay, the bus will be cross. Some other bus will cross your bus with less speed. Actually, VA bus speed is, for example, 50. This is, let's take 75. But while crossing, you feel only this speed of the bus is 25 km per hour only. Okay. But actually, this bus speed is 50. Actually, this bus speed is 75. But while we crossing, you feel this bus speed is only 25. Okay. Suppose the bus will travel in opposite direction. Actually, this bus speed is 50. Actually, this bus speed is 75. But while it is crossing, immediately crossing, you feel immediately crossing, sound will come like that. Okay, so that when it is crossing immediately, at the time you feel from each bus they feel like that the speed of each bus is with respect to A to B or B to A, that 50 plus 75. Okay, so while crossing the time, okay, you are feel the speed of B bus is 125 km per hour. Okay, how? Because in the first case the speed is constant. In the second case the speed is, the distance is reducing. Okay. Then third case, in opposite, the distance is reducing and increasing. But previous case, the second case, distance reducing, after that increasing in a forward direction. But now the same thing it will happen in opposite direction. Okay. So please, how to find that relative velocity? See that. So this is your bus or train, anything. So it is the A. This velocity VA is traveling this direction. Okay, the one more train will come. Okay, it is very close to the nearby track. Okay, so that velocity of the train is B in opposite direction, but it's near track. Okay, near track. Okay. So in this situation, it will be moves close to each other, towards each other. So at the time what happens, this distance is reducing. So at a particular time it will be cross. So like that only, initially some distance is there, then it will be reducing. At particular point it will be meet at particular distance. Okay. Then after cross one another, after cross one another, then again the distance is increasing, but it is away from one another. Okay, see that. So like that here, see that. Okay, but that depends upon the speed of the A object and B object. The slope nature will be different. Suppose the A object, what is that here? The A object speed is very high, means it is the slope like this. It's the A object. Okay. The B object very speed in opposite direction, meaning the slope is like this. Okay, so that depends upon the speed, the slope value will be changed. But anyhow, the common factor, that one is opposite direction, one slope is negative direction, that one is a positive direction, then another one is negative direction. Okay, that means opposite direction. So now let's see that if VA and VB are opposite sides, that means opposite direction, that is the meaning. Then the two objects meet at a point. Yes, the two objects meet at a point. Okay, for example, okay, same thing. Okay, I simply said object, instead of object maybe they gave bus or train something. If the two objects under the concentrations of the two trains, let's take like two trains, okay, then a person sitting on either side the other train seems to go very fast. Okay, so the one person is sitting in this window, then another one person sitting in another train, this window. Okay, what they feel while crossing? What they feel? They feel very high fast. Why? Because their relative velocity becomes, the generally relative velocity formula actually what? Relative velocity of A with respect to B is relative velocity of A minus relative velocity of B. This is common formula we know. But you know very well, VA is one direction, VB is opposite direction of VA. So here VB become minus sign, one more minus sign. So I mentioned here. VA minus of minus VB, minus of minus plus, so VA plus VB. So that only I told, this is 50 km per hour, this is 75 km per hour, so totally this is 125 km per hour. So the speed is increasing. Okay, so now you know that in different cases, if it is rest position what happen, or if it is the uniform speed what happen, or the speed is increasing or decreasing in a forward direction what happen, and the same speed is increasing or decreasing in the opposite direction what happen. So like that the different types of velocity we compare with the different situation. Okay, so now I hope you understood what is the relative velocity, then how we want to expose. Okay, thank you.